Hi, how you doing?
Hey Jono, how are you?
Fine, thank you.
Yeah. I have a serious problem here. I'm on top of the mountain. And my car, it's only 35% battery left I have in my car. So I can't go back home.
What are you going to do?
Yeah. Yeah. I don't know. I just called one of my distributors to help me to charge the vehicle. I'm not sure if we can do it right here on top of the mountain. Yeah, it's beautiful. That's the good part. But the bad part, it's I hope I'm not going to be forced to sleep here during the night.
You're going to have to get yourself out of this predicament because I can't come over there and help you. What with this virus lockdown?
So now let's take a look inside the electric ambulance. It's not much, but it's expensive. So Lucian, what do you have inside?
So we have three inverters, 10 kVA each one. Why we have three? Because we need one inverter on each phase. Our plan is to charge the vehicle using a three-phase charger.
Okay.
So this is why we need three inverters. And then we have these four batteries. As you can see, it's lithium, 25.6 volts and 200 amp hour. So in each battery we have something like 5 kilowatt hour, in total something like 20 kilowatts hour.
20 kilowatt hour of energy that we're going to transform through the inverters in 400 volt.
Yeah.
That we want to push to the electric car,
Yeah.
inside the car. That doesn't look like much, but it's just for the purpose of showing it can be done.
Yes.
But in reality, will I be able to make an electric car ambulance?
Yeah, of course. So probably you need more batteries if you want to go to help more vehicles. You need probably more power, not just only this 20 kilowatt hour. But yeah, you can do it. So if you want to do it like a business, this is what you need: three inverters and some batteries, and that's it. So during the day, you're gonna help electric vehicles to, I don't know, to recharge a little bit, enough for them to go to charge to a charging station. And then at the end of the day, you go back to, I don't know, your office, your home, connect everything back into the socket and recharge the batteries. And then next day, your business can continue.
And this is why the lithium batteries are very important, because they are less weight than the gel and the lead batteries.
Weight, volume, you can charge it and discharge it very fast. So this kind of battery can be charged in less than 1 hour and discharge and charge back in less than 1 hour.
So if we used the old generation batteries on gel, how many batteries would I need for the same capacity and the same power draw?
No, this vehicle is not able to sustain the weight of those batteries. So it's the difference is huge.
So this is really next gen, and this is the latest technology in using lithium power to recharge electric cars, isn't it?
Yeah.
So lithium power, inverters, all the equipment we need, even some next gen prototype things. But at the end of the day, this is what you need to push power to the car. Let's do it.
So let's try with this one first. So this is what we need this time.
Okay. So what are we actually using? What's this?
So we are using the charger that the vehicle came with. This one, the mobile charger.
Okay.
It has an adapter, so you can charge it with a normal socket, normal AC socket, or you can replace it with this three-phase socket. And in here we have a big three-phase socket, this one, and this one is a smaller one. And this is why we have an adapter. So this is the adapter.
Theoretically, we could have used the 230 volt, the two-phase.
Yes, the single phase.
The single phase.
Yeah.
So theoretically, we could have used the single phase with only one inverter.
Yes, but we don't want to spend the entire day here.
Of course.
So let's try with with more power. Okay, so now we have the charger connected to our socket, and we should have power. Actually, we have, it's green.
That's important. Whenever you see red on a Tesla charger or on a wall connector, you see that's bad news. You cannot charge. And that's basically the problem with generators and battery packs when you don't know what you're doing.
Yeah, we have something special inside our inverters. It's called ground relay. So it's actually, you can configure the inverters to connect the ground with the neutral. And this is why this charger, it's working here completely off-grid with a missing ground.
Let's connect the car and see if we can draw some power.
Am ținut-o prea mult. So, is it charging?
Come see.
Actually, he can see there. So we are 3 amps, 4 amps from 16. And the 3 in front of the 5 represents the fact that we are charging with 3-phase.
But I can see it's going up.
Yeah, it's going up.
7, 8, 9, 11 kilowatt.
Yes, we are charging with 11 kilowatt. 16 amps per phase, charging with 3-phase.
So that's the maximum power you can draw on a typical Tesla. The Model 3 right there and the Model S can draw 11 kilowatt on 400 volt on three phase, yeah?
Yes.
So let's double check. I know we can check the batteries and see how much power we're actually drawing.
Here on the right side you have AC loads. You can see that we are drawing something like 3.4 kilowatt on each phase. So from the batteries we are discharging with 200 amps at 48 volts.
And all of that coming from these 4 lithium batteries with those 3 inverters. No noise, no smoke.
Yes.
Lucian today brought us a different kind of Tesla. He's been hacking his own car, and we are not going to charge with only 11 kilowatt. How high can you go?
Yeah, on this vehicle, yeah, you can say hack, but it's an official product. For this Model S, it was possible to add another internal charger. So instead of charging with only 11 kilowatt, you can modify this vehicle to charge with 22 kilowatts.
Did you know about this? Because I didn't.
Yeah, it's possible.
How did you know about this? Was it official?
Yeah, it is still official. So you can buy it from and install it at Tesla. But I've installed it in Romania. There is let's say an unofficial Tesla service, and they are able to do that.
There's no official Tesla anything here, so it's okay.
Yeah.
I didn't know that. On my Model 3, I know I can only have 1 charger, but the Model S supports 2 chargers on AC.
Yes.
So this is what you get with a Tesla mobile charger. 11 kilowatt and that's it.
That's the maximum. And most of the time, that's the maximum of the car. The car can charge on AC. But because this vehicle has 2 AC chargers, we can, actually the car accepts 22 kilowatt, but the charger is not able to
supply that.
To supply that, yes.
So how can we push 22 kilowatts to the car?
We have a prototype here. So it's a Victron charger for electric vehicles.
I've been waiting for this for the past year.
Yeah, actually this is yours. You'll be part of the let's say testing program.
No, again?
Again, and next week we are planning to install it.
Yes. My precious.
Your precious. That's your precious.
I've been actually waiting for this for a long time. I'm a beta tester for another wall connector back home.
Yes, older version.
And I honestly hope this one will do the job because I want to charge from my solar panels. But that's a different story for a different day.
Let's explain you next time what this can do.
Okay.
But in this moment we will use it like a normal charger, and that's it. Okay. So let's try to do that. So first let's unplug the old one, the Tesla one.
The precious. It's so blue.
Yeah, you can see we don't have the logo yet. And this is a 3D printed case. So it's not even...
It's not the latest and that's okay.
No.
That's nice, having friends supplying prototypes. When will it be actually available? So we are shooting this in April 2020. When will it be available in the market?
The plan was to have it available for Intersolar this year. But because of this pandemic thing, everything was a little bit delayed. So I'm not sure yet. All the tests are very advanced. All the developing, it's almost finished.
Okay.
So what we are waiting now is to receive the final case from the factory. So yeah, this is the charging station. Let's plug it. So immediately after plugging it, the charging station will detect that it's vehicle connected. And in here you have a slider and you can select the charging power. In this moment we have 6 amps. So the vehicle will, I think you can put it here.
Okay, so we can see how much power it's already drawing. And I can see we are going up to 2 kilowatts.
Yes, same information, it's there and there, measured in...
3 kilowatt, 3.3 kilowatts, so that's 6 amps.
It says charging 3P, that means charging with 3 phases. So if you have a single phase vehicle, you will see charging 1P. But this one, it's able to charge...
In 3 phase.
Yes.
So we are now capped, limited at 6 amps. How high can we go?
We can try. So first let's go to 15 amps and let's see if you can do 15 amps.
So that's roughly going up to 8, 9, 9.5 kilowatt.
Yeah.
I've already seen 11 kilowatt. I want to see more than that.
Let's try 20.
Okay, going up. And now we went above 11 kilowatt. That's the standard charge on a Tesla. And we are already pushing 13.7 kilowatt, 0.6.
Yeah, you can see also in here we are drawing 13.8 AC loads. And we can check it also on the vehicle screen. So 20 amps and 14 kilowatts. And it says in 4 hours and 25 minutes
We'll have a full battery. But if you put the slider to 90%, because a Tesla doesn't like being charged to 100%.
Yes.
How fast can I go to, let's say, 80% from 46 on this kind of charge?
We can try. Let me change it to that value. 2 hours and 40 minutes.
So you're actually charging much faster if you don't go above 80%. So the moment of truth, I'm gonna give it full power. Okay, 32 amps. Oh my God, that's 22 kilowatt. And that's a first. That's the first time I see a Tesla charging on AC with 22 kilowatt.
You can see it in there also.
Crazy! And since we started, we already pushed 1 kilowatt hour inside the car. So your range went up 2%.
Yes.
How is that even possible? How can you draw 22 kilowatt from a 20 kilowatt hour battery, let's say?
Because it's lithium, and lithium can be discharged with, let's say, 2 or 3 times the capacity of the battery.
2 or 3 times. So
yeah,
theoretically, you could draw 60 kilowatt.
You can discharge this battery in half an hour and charge it back in another half hour.
Okay, but you need a lot of solar panels or some kind of power for that.
To charge it back, of course, you need a lot of power.
But it can be done. And this is a first from what I know.
Yeah, probably.
And you've seen it here first. So if you like our experiment, hit the like button and share it with your friends. And I'm sure there's at least one electric car lover out there that's gonna find some use for what they've seen here today.